Hey everyone, Professor Baldwin here. This time we have a factoring problem that has multiple steps. First step, GCF. And the GCF here is 3z squared. Factor out that GCF, 3z squared, and we're left with the trinomial 2z squared minus 7z minus 15. Now we need to factor this trinomial that's left behind in the parentheses. But notice that the leading coefficient of that trinomial is a 2. Since it's not a 1, the most efficient way to factor this is to use the key number method and grouping. The key number method is a times c, so that leading coefficient 2 times the constant term at the end, negative 15, that's negative 30, and then b, the coefficient of the middle term, negative 7. And we're looking for two values that multiply to negative 30 and also add to negative 7. 2 times 15 is the first possibility I think of, and there's no way for that to ever add to 7. Next would be 3 and 10. Well, since we need them to multiply to a negative number, one of them is going to be negative and one positive. And notice if we have a negative 10 and a positive 3, they multiply to negative 30, and they also add to negative 7. So what we do is we use these two values to rewrite that middle term of negative 7z. So keep that GCF. Keep the first term of our polynomial. Now we rewrite that middle term as negative 10z plus 3z, because together those are negative 7z, minus 15. Now that we have 4 terms, we're going to factor those by using grouping. Again, keep that GCF. And now I like to put in brackets because I'm going to start factoring the inside polynomial and it'll produce some parentheses. So the first grouping has 2z in common, and that leaves us the binomial of z minus 5. And remember, with grouping, we need that second group to also give us a binomial of z minus 5. And to do that, we have to factor out a positive 3. Now that we've gotten that polynomial factored down to 2 terms, we're going to factor out that binomial they have in common, z minus 5, and it leaves the binomial 2z plus 3. And don't forget that GCF 3z squared.